All right, this lesson is a little bit more practice for factoring. The first step of factoring is to look and see, is there a common factor? Nothing goes into 8 and 27, but I see that they both have an A in common. So when you see something in common, you put it out front of the parentheses. And then you go ahead and divide by it. So basically I'm dividing by A. That tells me what goes on the inside. So that's going to leave 8b to the third power plus 27a to the third power. Alright, because these a's cancel out, and that a cancels out one of those a's and leaves a to the third power. Now, hopefully you'll recognize this blue as the sum of two perfect cubes. 8 is a perfect cube and 27 is a perfect cube. And we learned that anytime you factor the sum or difference of two cubes, it is always going to factor as a binomial, a two-piece, times a trinomial, a three-piece. Now this a right here, I'm just going to bring that down. Okay, that doesn't go away. So the binomial is just the root of all of these. Where does it come from? So you could make a list very easily of the first 10 perfect cubes. Now 8 and 27, where does 8 come from on this list? See, there's 8. 8 comes from 2 to the third power. 27 comes from 3. So with that in mind, the root of 8 is 2. Okay, obviously b to the third power comes from b. Bring down the sign. 27 came from 3, and a to the third power came from a. Alright, so it's the root of each one of these parts. That's how you get the binomial. Now, the trinomial has 3 parts to it. It has a beginning, an end, and a middle. Okay? Let's do the beginning and end first. The beginning and end come from just squaring these. If I take this and I square it, I'm going to get 4b squared. If I take this and I square it, think 3a times 3a, I'm going to get 9a squared. Now this is a term. It must be added, so put plus. It'll always be plus. That just leaves the middle term. The middle term comes from multiplying these two things together, and we do the opposite sign. So this is addition, so I'll do minus. 2b times 3a. That is 6ab. Alright, and that's it. That's the answer. Alright, look at number 2. Okay, same thing. This is the sum of two cubes. Alright, because 1 is a perfect cube, because 1 to the third power is 1. So again, this is going to factor as a binomial and a trinomial. Alright, a two-piece and a three-piece. The binomial is just going to come from these two things. P to the third power comes from P, keep the plus sign, and 1 to the third power is 1. Okay, so those are the roots of each of these. Now, so I'm going to have my beginning, my end, and my middle. Alright, the beginning and the end, you just square these. If I square this, alright, I'm going to have p squared right here. If I square this, I'm going to have 1. Alright, plus 1. So it's just a matter of where the middle comes from. Now for the middle, we multiply these. 1 times p is p, but we do the opposite sign. So we do minus p. Alright, it's multiplication. And that's it. That's the answer. Alright, look at number 3. What is the first step of factoring? see if there's a greatest common factor, GCF. Both of these have x in common. So before you do anything else, you should pull that outside of parentheses. That will leave behind x to the third power minus 1. Okay, please understand it's a 1 right here. Let me move this down a little. When you do a GCF and you pull it out, remember that you divide by that. Alright, this x cancels out one of these, so that's why it's x to the third. But these cancel each other out, but they're not gone. Anything divided by itself is 1. You know what I mean? Just like 5 divided by 5 is not 0, it's 1. So that's why this is a 1. Alright, and then the rest of it is exactly like problem number 2 that we just did. It's just like number 2. Okay, so we keep the x, but we keep the x, but we go binomial, trinomial. Alright, the binomial is just going to be x minus 1. For the trinomial, I square this, I get x squared. I square this, I get plus 1. Then I multiply, and I get negative 1x, but I do the opposite, so I do plus x. And that is it. Okay, number 4. I definitely see some common factor going on here. Both of these are divisible by 2. They both have x's and y's. So the GCF is 2. They both have at least one x, and they both have at least one y. So 2xy is my GCF. Let's see what that leaves inside. Now remember, to see what is left, I will divide. So again, look what happens. 14 divided by 2, well, that's 7. X takes out one of those x's and leaves x. These y's cancel out completely, so there's no y. All of these cancel out. Bam, bam, bam. So that's 1. Again, it's not 0, it's not nothing, it's a 1. There's nothing else we can do with that. 7x minus 1, we can't factor any further or anything. So that was it, just GCF. Alright, what is the first step of factoring? GCF, Mr. Burton. All of these are divisible by 6. 6 is the greatest common factor. So bring that 6 out. Okay, and then, divide everything by 6. If you do that, what you get is x squared minus x minus 2. This can be factored further. So keep the x and keep going. So x squared is x times x. Alright, 2 can only be 2 times 1. Alright, inner, we have 2x. Outer, we have 1x. We're trying to get a middle of negative 1x. Okay? We can get that if we do, let's see, if we do a negative 2 and a positive 1. So there's my negative 2, there's my positive 1. A negative times a positive is a negative, so that works out. So this is the answer. Oh, by the way, I noticed on the quiz that we just took, a few of you, you would keep going and set these equal to 0, alright? Notice two things. The directions just say factor. Factor completely. Alright? It doesn't say anything about solving. So you are not going to keep going once you factor. Also, it wouldn't make sense to say solving because you solve equations. And these are not equations. There are no equal signs. So there was just a couple people. But the people that would take this and set these equal to 0, don't do that. If there's not an equation, you just factor and stop. Okay, let's take a look at number 6. I do not see a GCF on this one, so let's just go straight to the binomial situation. Now 9, it's either going to be 3 times 3 or 1 times 9. 25 is either going to be 5 times 5 or 1 times 25. Alright, let's start with the ones that are sort of close together. Alright, let's start with 3a times 3a and 5 times 5. Alright, if this doesn't work, we'll try other combinations. Now, inner, we have 15a. Outer, we have 15a. Okay, we are trying to get negative 30a. That's doable. It can make negative 30 if both of these were negative. Alright, so that would make negative and negative. Does that give us positive 25? Well, yeah, because a negative times a negative is a positive. So that means this is in fact fully factored. Alright, how about number 7? GCF. I see it. They both have x's and y's. Alright, let's see. X's, I see 7 x's and 2 x's. So they both have at least 2. So, basically bring out the smaller amount. So I'm going to bring out x squared. How about the y's? 9 and 3. Bring out the lower amount. They both have at least 3. And then you can divide. Okay, I didn't really leave myself enough space. So I will divide by my GCF of x squared y to the third, x squared y to the third. These two will cancel out 2 of the x's in the top, and so I will have x to the 5th power. These 3 will cancel out 3 of these, and that will leave y to the 6th power. Plus 1. Again, these all cancel out, but that makes 1. So that's it for number 7. Alright, how about number 8? Nothing, okay? If this were subtraction, I would do 4x plus 5. If this were subtraction, I would do 4x plus, I keep messing this up, alright? If this had been 4x squared minus 25, then we would have had 2x plus 5 times 2x minus 5, alright? But this is not subtraction. This is addition. Alright? Addition doesn't work like this. In fact, the sum of 2 squares is completely unfactorable. So number 8 is prime. Okay? You can't do it. Alright, number 9. GCF. They are all even. So I will pull out a 2. And that will leave 6x squared minus 11x minus 10. Alright? Now I will keep going. So binomial, binomial. Now looking at that 6, it could be 2 times 3 or 1 times 6. This could be 2 times 5 or 1 times 10. I'm going to start with 2 and 3 and 2 and 5. Alright, see how far that gets me. So that would mean 2x and 3x. And then 2 and 5, except for I'm not going to put the 2 here, am I? Because that would make a GCF with this 2. So I won't waste my time on that, but I will try 5 here and 2 here instead. No GCF anywhere. Okay, now let's check the inner, outer, middle situation. Inner, I have 15x. Outer, I have 4x. The inner plus the outer must equal the middle, which in this case is negative 11. Can I get it if I pick the signs right? Yeah. If this were negative 15 and positive 4, that would make negative 11. So there's my negative 15, and here's my positive 4. Does negative 5 times positive 2 make negative 10? Yeah, a negative times a positive is a negative. So this is the completely factored form. Alright, number 10. GCF? No, that's prime. So I will go straight to binomial times a binomial. 12 could either be 3 times 4, or 2 times 6, or 1 times 12. 15 is either 3 times 5, or 1 times 15. I'm going to start with the bottom level, 3, 4, and 3, 5. Okay, so that would make 3x and 4x. Now again, when I try the 3, 5, I will not put the 3 here, because that would make a GCF, and that shouldn't happen. I will try 5, 3 though. Now let's check the inner, outer, middle. Inner, I have 20x. Outer, I have 9x. The middle is negative 11x. This is looking promising. Like 20 minus 9 is 11. So that means this should work. Let's see, I need the bigger number to be negative, so the negatives will win. So negative 20 and a positive 9 will make negative 11. So here's my negative 20, and here is my positive 9, outer. Does that make negative 15? Sure, negative times a positive is a negative. So that would be how you do number 10. Alright, looking at 11. I see 4 terms, so I'm thinking grouping. Okay, so I'll group these two, and I'll group these two. Now the common factor here, let's see, they both have a p in common. Okay, so I'm going to put a p out front. So that's going to leave q minus 3. Alright, you know, I'll usually like to color coordinate this to make it more obvious. Okay, q minus 3. Over here, I see the negative 5 is the GCF, so I'm going to pull that out. Alright, and that's going to leave behind q minus 3. Notice it is minus 3, even though this is a plus here, because a negative times a negative would be a positive. Imagine multiplying by negative 5. I would get 15. Now, I am going to factor out this common factor of q minus 3. I'm going to put that in front. So that would leave behind the blue part, which is p minus 5. So there we just factored by grouping. Okay, number 12. GCF. I see a 2 common. X, alright, they both have x squared. Alright, they don't have y in common, so I'll stop there. Then I will divide by my GCF. So 2x squared, 2x squared. Alright, let's see. The 2's cancel out, x squared, x to the 5th power, that makes x to the 3rd power. Alright, 16 divided by 2 is 8. The x squared is canceled out, so that is y to the 3rd power. Alright, anything special about what's inside of here? Can I go any further, or am I done? I can go further. This is the sum of two perfect cubes. So I'm going to keep my 2x squared out front. But I'm going to factor this as a binomial and a trinomial, the way the sum of two cubes always goes. The binomial is just the root of each of these things. X to the third power comes from x. Alright, I'll bring down the plus. 8 comes from 2 to the third power. Right? Remember the chart? 8 comes from 2. And of course, y to the third power just comes from y. So that's where the binomial comes from. Now for the trinomial, I have my beginning, middle, and end. Okay? I always do the beginning and end first. The beginning comes from squaring this, so x squared. The end comes from squaring this, so that's positive 4y squared. The middle comes from multiplying these together and taking the opposite sign. So this is going to be negative 2xy. So this is the full answer. Okay. Alright, last two problems. There is a GCF here. They're both divisible by 2. So if I pull that out, so I've got 2, and then I've still got x to the fourth power minus 16. Alright, now it's harder to see because we haven't done one exactly like this before, but this is the difference of two squares. Okay, you know how it's similar to if I had x squared minus 16, right? I would do x plus 4, x minus 4, right? Because x times x is x squared. I'm going to do almost the same thing, but it's x to the fourth power. So let's see, I've got 2. Now I can split this up, but instead of x and x, it's going to have to be x squared and x squared, because x squared times x squared would make x to the fourth power. Alright, the 16 is still going to be plus 4 minus 4. So there I factored it. Anything else? Yeah, this one can go more, because this is the difference of two squares. Okay, so I'm going to keep this part. 2x squared plus 4. That part stays. This part can factor further. Okay, doing this right here, because this is the difference of two squares again. So this will be x plus 2, x minus 2. Okay, so this will be the answer. Okay, last one. No GCF. So this is just going to be a relatively straightforward binomial problem. So it'll be 3y times y. Then 10 is either going to be 2 times 5 or 1 times 10. Let's start with the 2 times 5. Okay, 2 times 5. If this doesn't work, I'll try 5 and 2. Inner, outer, middle. Okay, inner, I've got 2y. Outer, I've got 15y. I'm trying to get the middle of negative 1y. Okay, that's not going to work. So let's try doing it the other way around. So, yeah, I'm coming. Alright, so I'm going to try doing 5 and 2 instead. So that's going to make that 5y inner and 6y outer. You know what, I can get a negative 1 out of this if I let the bigger one be negative and the smaller one be positive. So that would make this positive 5 and this would be my negative 2 to make the negative 6. Will I get negative 10? Sure, a positive times a negative is a negative. So this will be the final answer. Alright, that's how you do it. I will see you on the next video.